All right, section 1.4 is all about functions. Let's start in this top right corner, and I'm going to clarify something on this definition, just to kind of shorten the definition to make it a little simpler. So a function f from set A to set B, is a relation that assigns each element x in the set A to exactly one element y in the set B. The set A is the domain, or the set of inputs, of the function f, and the set B contains the range, or the set of outputs. The way I typically define a function, and this is just going to kind of shorten that a little bit. I'm going to say every input has exactly one output. And I'm going to underline exactly one. The reason I'm underlining exactly one is because sometimes you'll see some situations where an input, an x value, has more than one output. It has at least one, but we're looking for exactly one, no more than that. So some characteristics of some functions, and we're going to take a look at those images right next to it. So each element in A must be matched with an element in B. So every element in A has to have a pair. Some elements in B may not be matched with any elements in A. So that means not everything in B has to be used. Everything in A has to be used, but not everything in B has to be used. Two or more elements in A can be matched with the same element to B. That's not a problem. So two inputs can have the same output. And an element in A, the domain, cannot be matched with with two different elements or more than that in B. So, and again, every item in A can only match with one item in B. But one item with B can match with two different items of A. That's not a problem. Let's take a look at a couple images here. So, in this set here, the time of day, let me zoom out a little bit so that my head's not covering it. There we go. So this time of day is, this kind of representation of this graph is also a representation of this data set down here. So looking at this, at 1 p.m., it was 9 degrees out. We see that right here. At 2 p.m., it was 13 degrees. I'm assuming this is in Celsius, otherwise this is cold. It's even kind of coldish for Celsius, but this would be very cold. So for 2 p.m., it was 13 degrees. At 3 p.m., it was 15 degrees. At 4 p.m., it was also 15 degrees. So 3 and 4 p.m. both share that 15 degrees. That's okay. At 5 p.m., it matches up with 12 degrees. At 6 p.m., it matches up with 10 degrees. So every time of day has to have a temperature. You can't skip it. So like 1 p.m., 2 p.m., 3 p.m., also you could probably do some subsets like 1:30 and whatnot. But you'll notice that's kind of like, this is, let me label this as A. That would mean this group over here is B. Now, it doesn't match up with every element in B. So like at 1 p.m. it was 9 degrees, 2 p.m. 13 degrees, 3 and 4 p.m. was 15 degrees. We didn't measure the temperature where it hit 14 degrees, between 13 degrees and 14 degrees. We didn't measure that, and that's okay. We don't have to use every temperature. Like, we're also not using 100 degrees Celsius because that would be stinking hot and it would literally be boiling out. We're not using every temperature, but we are using every time of day. Now, down below here, we've got 4 examples that I want us to take a look at, and I want you to determine whether it is a function or not. Let's do the first one together, and I'm going to have you do the other 3 on your own, seeing if you can think of some things. So the first one, it says you've got some inputs here. Those are your x values. Let me zoom in on that. So your inputs are your x values. You got inputs of 0, 1, 2, 1, and 0. So your outputs, when the input is 0, the output is -4. When the input is 1, you get an output of -2. And then we have 2, 0, 1, 2, and 0, 4. So is this a function or not? Unfortunately, it is not. Sorry, let me write that down. So it is not a function. Going back to the simpler definition that I was using, each input can only have exactly one output. Taking a look here, we've got repeat inputs, and they have different outputs. So you could say x equals 0 has 2 outputs. You could also say something pretty similar for x equals 1. You'll notice at x equals 1 and this x equals 1, you've got 2 different outputs. That doesn't quite work. What I want you to do is, with that in mind, take a look at these next 3 examples, pause this video and see if you can come up with, identify whether you believe that there are functions or not. So again, determining whether this is a function, this is a function, and this graph is a function. So pause the video and come on back. All right, you've clearly paused. You didn't just wait for me to stop or start talking again. So this one, the other table, I think my lights just went out in here. The other table, is this a function? Yes. It's a function. So one thing on here that was trying to trick you a little bit, let me shift this a little bit. It is trying to trick you a little bit because the outputs are repeated over and over and over. That's fine. The outputs are repeated over and over and over. That's not a problem. The inputs are the ones that can't be repeated. So 0, 3, 3, 3, 9, 3, 12, 3, 15, 3, those all have the same value. That's or the value for your output, and that's okay. An example of this might be, let's see, some places give different, some restaurants give different prices for different ages, but for this case, if you're a 0-year-old buying a meal, first of all, you probably shouldn't be eating that meal. That's besides the point. Maybe that kid's meal is $3. If you have a 3-year-old that is you're buying a meal for at a restaurant, probably gonna be $3. 9 years old, $3. 12 years old, $3. 15 years old. Now, oftentimes at restaurants that would probably consider yourself an adult, which is weird, but it's still $3. It's okay. You can have different or the same price for different ages, same output for different inputs. This one on the lower left, it's labeled as B. We got that from a different image, that's why that letter is there. This one is not a function. The reason being, oops, sorry, my stylus got a little wonky. The reason being is x equals 2 has two outputs. All right, and for this graph, this one, the graph might look familiar. It looks kind of like a parabola. It looks like a parabola that's been shifted down a little bit. This one is a function. So it is a function. Now, some of you might remember back to when we first learned about graphs and functions and whatnot, how to test it. You might determine or use it you might determine whether it is a function or not. There we go, using the vertical line test. If you draw a vertical line through any point on the graph, in this case we only have these 5 points, as long as those vertical lines only touch one point on the graph, it's perfectly fine. It is a function.